Hey folks, Quilly18 here, and welcome to a brand new tutorial for Unity. This is going to be all about networking, something we haven't touched in quite a while. The last time I did a Unity tutorial, the built-in Unity stuff was pretty meh, so we did Photon Unity networking. But since then, there's been a lot of great work, including sort of the new Unity networking code, which a lot of people refer to as UNet, is wonderful. There's lots of high-level stuff, mid-level stuff, low-level stuff. If you want to get into nitty-gritty, it's wonderful. They do have a tutorial on their website. There'll be a link in the doobly-doo, and you should actually go and go read through the tutorial or do that tutorial right now. Go ahead. I'll wait for you. Okay, are you back? If you're like me, that tutorial left you with more questions than answers. And yeah, I did not think it was a great. It's very fast, like 30 minutes. You've made like a quasi first-person shooter, but yeah, it leaves a lot of weird questions behind. So what we're going to do here is we're going to go a little bit more in depth, explain more of the mechanics, both in terms of just sort of, general sort of multiplayer, networking, client server kind of questions, as well as some specific Unity stuff. So we're going to start with an empty project over here, and we're going to dive right in. First of all, just to make sure we got some of the terminology and some of the concepts in mind, little beautiful Photoshop diagram over here. The idea of client and server. The clients are like the individual players that are running the, your executable on their particular computer, and they are playing the game. Now, they don't connect to each other. Imagine if you're playing, you're doing a big game, you're doing a PUBG with 100 players, or World of Warcraft, thousands of players. Not every client connects to one another. That would be insane. Instead, all of the clients connect to a server. And the server, in its most basic form, is simply responsible for something like client A says, I did a thing. I shot a bullet. So it sends a message to the server to say, I shot a bullet, or I moved 3 pixels to the left. And then the server goes and repeats that instruction to client B and C, and so on and so forth. This server could be more or less authoritative as well. For example, if you're doing something like, say, League of Legends, then the server in that case is also checking things like, well, do you have the mana for it? Can you see your target? Is this all legal and things like that? If all the things are true, then it does it. Otherwise, it just sort of blocks it. So the server might check those things, or it might not, depending on what kind of role. Now, in a lot of smaller games as well, the server, in this example, this would be a dedicated server. However, there's no reason that the computer that's the server, that's the host, can't also be a client. So that is actually quite frequent. That happens a lot of these smaller games. One player starts the game, other people connect to that player, but that player who's running that quote-unquote server is also running a client. Now, you still sort of want to think about it, even though this is actually probably all in one executable, it's still really good to think of that sort of split in the logic, because, well, for lots of reasons that'll become obvious as we proceed forward. Also, matchmaking servers are sometimes a thing, and what happens in this case is, where's my drawing layer? Is instead all the clients basically connect up to the matchmaker server like this. One of the clients starts a room, and then the matchmaker server has the connection basically to the actual server over here, which is probably still running on a user's client machine. But that way the clients, because otherwise these guys, the only way they can get to the server is if someone says, well, here's my IP address, here's how you connect to me. Otherwise what they do is they connect to a known matchmaker server. The matchmaker handles all that and also avoids tons of problems with like firewalls and all kinds of nonsense that become very difficult to deal with. Okay, done with that quickie little overview. Let's start writing a little bit of code. So the first thing we need in our project here is we do need one object that is responsible for maintaining the network connection. Because once you create a network connection, it really can't just be broken. It's got to be on something that's never going to go away. So we're going to create an empty game object here, and we'll call it Network Manager. I think that's probably fine. Network Manager. Okay, now, we, at this point, could start a script and start writing a script from scratch by implementing some of the lower level networking API stuff in Unity. However, Unity has provided us with a great many high level network scripts. So if add component, go to network, great many high level network scripts. Now, none of these are magic. We could write an exact duplicate of these on our own. That would be perfectly fine. And some of them you will want to tune for your game to tweak a little bit of behavior here and there, especially with things like, just like menus and how you handle the connections and making that a little bit slicker. But, even then you probably won't need a full rewrite more than you could just derive a subclass from one of these and overwrite some virtual functions. That may be going over your head a little bit over here. That's fine. None of that's important right now. What is important is that we get a network manager object over here. So this is a script called network manager. It happens to be on a game object called network manager, but it doesn't have to be the same. This could be called Bob, that's fine. This network manager script is responsible for providing us a great amount of access to the actual network code, either as a server or a client. It also does a few other things for us that will be convenient going forward. We can wait on some of that right now. One of the things it does is it sets us up to not be destroyed on load. When you load a new scene, this object's going to stick around. And that's important. You're probably going to want to create this object in some sort of like init scene, even before the main menu. The idea is the scene will go and preload these objects once, and then they're always going to exist as you go through your program. Or maybe you want to go, you maybe you're going to want to do it instead when you hit on multiplayer, and then it'll create it, or something like that. We'll see. But it sticks around forever. It also runs in the background, because normally when you tab out of a Unity application, the application pauses, and that would be bad for the network stuff, because then it would, stop listening to the network and probably just time out and get disconnected, and that would be terrible. Now, so by itself, if we hit play, nothing happens at all. But, so to do anything, we need to send instructions to the network manager. And this actually probably would be where we'd write some code, but for now, we can go back to the network category and add the network manager HUD, heads up display, a little GUI interface, basically. When we hit play, we now get a series of buttons here. I think they intentionally made them as ugly as possible because you really want to go and write your own over here. We're going to ignore the enable matchmaker over here, although you can click on it and do some things, and it's going to use your Unity services over here. Unity provides a free, I think, 20 concurrent user matchmaking sort of server available for you, which is just very nice and lovely. So you can create rooms and join rooms and things like that. We're just going to deal with these other three buttons for now. That's going to be fine. If we hit this button, this will start just a server on this as part of this executable. That's all it is. This is just acting as a server and nothing else. Of course, we could go to File, we could build an executable, and then that one could join as a client and connect to this. Okay? So server is the server, client is just a client, host is the pair. If I click this, what it's going to do, it's going to use itself as a server, and then it will immediately connect to itself as a client. But it's important to know that both those roles still exist. This one executable is both a server and a client, but those are two very different jobs that it's doing at the same time. We also get our first error over here. So let's talk about this error. Player prefab is empty on the network manager. Please set up a player prefab object. The basis of the Unity networking setup is such that by default, I always hit Control-S compulsively whenever I start doing some stuff. So let's just make a dummy scene here. There we go. So we have a scene. I always name it like that just because of whatever. Okay. What was I saying? The basis of the Unity networking setup tends to be when a client connects to a server, you should spawn an object, and this is the player object. Okay? The one and only for that player object. Each player is going to have a player object by convention. Now, if you went and did the Unity website's tutorial, that player object is like, I don't know, they spawn like a capsule or something, right? They have a capsule, and they move this thing around, and this is the capsule that shoots and everything like that. And I mean, that's fine, I suppose, but I'm going to make a case here, and I'm going to make a statement that the player object should not be a physical object in your game. And the reason I say that is because what happens when you die, right? This is a first-person shooter. So this object over here is you, and it's also your player object. What happens if you die? If you destroy this object, I don't know, but I bet you really weird things happen. Because that's not really what it's designed to do. You're supposed to have a player object in the game at all times. You can probably respawn it, but it's funky and weird. And then what happens in games where it's not a first-person shooter or a third-person shooter, instead it's a strategy game like StarCraft or Civilization, where you don't physically have a presence in the game. So what then? I'm going to make a case that it's a much better organizational style that you assume the player object. So that, again, when we connect, we got an error here, player prefab is empty. It's because our network manager under spawn info wants to have an object that it spawns every time a player connects to the server. And then that object will be assigned to belong to that player, to that client. I say that object should be an invisible empty game object with some scripts on it, sure, but otherwise is not physically present in the game. And that, whether you're making a first-person shooter or something like StarCraft or a turn-based board game or whatever, that can just persist and contain your player info. And I think that'll be a great way to go. So let's create an empty object. And let's call this, I don't know, the player connection object. Player connection or something like that. This is the player object. I suppose I could just call it player object. Okay, there you go. Player object, because that's actually a lot of the terminology they use internally. Yeah, okay. So every time a player connects to our server, a player object will be spawned for that player. Now, it has to be a prefab, so we're going to drag it down here. And then what we're going to do in the network manager is we're going to try to drag this object there. It's not going to work. It's going to give us an error. Oh, come on. Player object, drag it into here. Boom. Player prefab must have a network identity. Network identity is a component. So if we go to player object, add component, go down to network, and go to network identity. Network identity is an object, or is a component that goes on a game object. And this gives you a way to identify this object on a network. Because normally in Unity, the way you reference or refer to different game objects is by like some sort of reference link or something like that. A reference in C# is basically like a pointer. It's pointing to some place in RAM and say, I'm talking about the object that's sitting in this location in RAM. Well, you can't do that in a multiplayer, in a networked game, because objects will have completely different RAM addresses on everyone's computer. So instead, we create this network identity system where the first object that gets created, I think it's actually number 1. I think it starts at 1 for some reason instead of 0. I don't know why, but there it goes. So the first object that exists on the server is ID 1. So basically that's going to be the first player that connects, their player object. And then they shoot a few bullets, and that's going to be object 2, 3, 4, and 5. And then the next player connects to the server, and their player object is going to have ID 0. And then they're going to do stuff, and it keeps going like that. And then that way, when the network, the client and the servers talk to each other, they just say, oh, object 18 just got shot or something. So that's how they can refer to each other. So everything that is going to be networked needs to have a network ID. Now that's very different from non-networked objects. For example, let's say we had a ground plane. So this is the ground. And we have some sort of, I don't know, some sort of cube, which we're going to bring up a little. And wow, that is really bright. Can I just lower the intensity some? There we go. Something like that. Some cube, which is just some sort of obstacle in the world or something like that. And these are not going to be networked. Maybe because they're static or something. But for whatever reason, they don't have to communicate anything about themselves on the network. So what I'll do is I'll actually, just for organizational purposes, there's no reason to do this other than it keeps things neat. We'll just call this something like non-networked objects. I just stuff things in there. You know, this may or may not be static. I don't know. It doesn't matter. But these things aren't going to be, they're never going to move or change or something in terms of stuff that's going to be on the network. So they don't need network IDs. They're still part of the scene. So every client will see the same thing. If I hit play here, right, I see the scene. It's there. And if I do the LAN host, oh yeah, I still don't have a player prefab. So this player object has an identity. If I go to the network manager, I can drop it in there now. Excellent. Let's try this again. We hit play. LAN host. There we go. So I am both server and client, and when I connected to myself as a client, a player object got spawned, and this belongs on the network. If someone else were to connect to the server afterwards, they would spawn their own player object, but they would also get a copy of the first player object. And so this could have some stuff on it. So let's let's make a new script. We'll make a C# script. We're going to call it player object. Like this, and just wait for it to compile. Nope. Compile. There you go. Excellent. We're going to throw it on there. And so the player object should have some information about the player. This can include things like, for example, the player name. Okay, embiggen. So yeah, it could have player name. It could have all kinds of data in here. That does things. Maybe it is a shooter. You keep track of your kills and assists and deaths and all that kind of stuff as part of the player object. But it's not actually a thing that moves around. Okay? Instead, what we're going to want to do at this point is actually have the thingy that moves around. Okay? So let's say Normally, in Unity, how would we do that? Well, we do something like, okay, we have a public game object, and it's my player unit. Sure, okay, right? It's my dude in a first person shooter. It's my Zergling in StarCraft. It's my scout in Civilization. It's whatever, okay? Player unit prefab. And so what I want to do is something like, since the player object is invisible and not part of the world, give me something physical to move around. And we do something like instantiate player unit prefab, like that, okay? And then we'd go back to Unity, compile. There you go. We got the slot over here. I'm going to drag. I guess I need to make an object. Let's make an empty, and inside of the empty, we'll put let's say a sphere. Now, again, I've talked about this many times before. This is a much better way. Instead of making your object the sphere, make your actual unit or whatever an empty game object, and you can attach scripts and everything to this, including a rigid body as well. But all your graphics here should be inside the object. That makes it easy to adjust them up or down if they're slightly misaligned, or maybe you need to rotate them or scale them depending on your modeling software. You can do that. You can also swap your graphics in and out very easily. I feel like I need to move some things around because we can't see anything. Let's take the cube and move it 2 pixels that way. Good. And then we'll just center this up. Not that it matters that much. Okay, something like that. Maybe we'll give it a little bit of color just to see. So I'm going to make a materials and create material red. Boom. Maybe just a little darker red, something like that. And drop them red material on the graphics over here in the player unit. Excellent. Okay. And rotate you so you're sort of in line with the camera. Lovely. Okay, so we have a player unit over here. So what we'd do is we'd make this into a prefab. We would then delete that. And so the player object, the player unit prefab over here would go right in here. And so we hit play. And we connect to ourselves like that, and there we go. So we have our player object, which was spawned by the network manager when we connect, and then the player unit over here. Now, there are several problems with this player unit thing here. I'm trying to think of a good way to demonstrate that. Okay, let's put in a debug.log. All right, and we'll put in a note in here. So player object.start spawning my own personal unit. Okay? So this is mine. I'm this player object, and I want to spawn my personal player unit over here. And what we're going to do for the very first time, and I mean, we could test it solo. Server, connect to myself, spawn my own personal unit, and there it is. But what I'm going to do is I'm going to go build and run. So I like to make a builds folder, and inside of that, we'll call it a unit tutorial, something like that. So it's going to make an executable for me. This way I can have 2 things connected. It's going to be lovely. Compiling. I wouldn't expect it to take this long, considering it's the world's simplest thing in the universe. Seriously. Okay, that was a long compile for some reason. So it's booting up. I'm going to just shrink the resolution a bunch and make it windowed and play. So this executable, I'm going to have this start up as a server. So it's going to be a host. Oh, yes. Got to be let through my, my firewall. There we go. So this is a host. So it's a server and a client. So it has created a player object, and the player object instantiated a player unit. Now what I'm going to do, over here in Unity, everything's clear, I'm going to hit play, and I'm going to connect to the local host. That's my own computer here, same as 127.0.0.1. I'm just connecting to myself as a client. So it's going to connect to that other standalone executable. And what's going to happen is going to be a little weird. In the debug log, I have 2 entries here for spawning my own personal unit. What happened? Well, if we look at our hierarchy over here, we see there are 2 player objects. That makes sense. Every player, every client that connects to the server gets their own player object spawned for them by the network manager. And each one of these player objects has our script on it, this player object script. Now these are just normal Unity game objects. Each one of these, before update runs for the first time, on each one of these, the start function gets run. That means for each one of these objects, they've both instantiated some prefab and spawned it in the world. Well, instantiated in the world. But this isn't connected to anything. There's actually currently 4 completely disconnected units, like the spheres, existing in the world. They have nothing in common with each other. And the problem is that this client here, this client running in this window, is responsible for instantiating 2 player units, one for each one of these. But that's not... It's feeling like it's hard to explain how the network is sort of failing here, but it's not being networked at all. And I guess the big emphasis is that this start function is running for each of the player objects, even though I only own one of them. Right? That's what it comes down to. I only own one of these player objects. I should only be executing code for one player object. I should not be executing code on behalf of some other guy's player object. And in fact, I'm not legally able to do it. The fact that this is not networked code is the only reason it's vaguely working. Because if I was trying to do anything networky on this object, it would fail outright because I'm not allowed to do anything networking on some other guy's player object. So let's see what we can do to fix this up a little bit, okay? So a few different things that we can do. First of all, we can check, hey, this player object that's running, does it belong to me? Or is this some other guy's player object? Now, don't get me wrong. Even for some other guy's player object, I might still want to run something in start. Just because, I might want to kickstart an animation or something. Because the animations, you can network some animations. There's a few different things, but maybe you don't have to. So maybe there's something I want to kickstart something, or I want to be like, oh, someone connected, I'll write something in the log, or maybe, oh, whenever someone spawns in, I want to have a shower of fireworks. So I might still want to do something in this start routine, even if this object doesn't belong to me, because I locally want to do something exciting when someone else connects. But it's important that I don't actually try to do anything to manipulate this object on the network, because I'm super not allowed to do it, and I'll get errors, is what's going to happen. So first is this actually my own local player object? How do we find that out? Well, just like with Unity's UI system, we have to include a new namespace of stuff over here. So it's Unity engine.networking. Makes sense. And here's the thing. We usually take this for granted, but every component that we add to our program is derived from mono behavior. Mono behavior is the thing that sets up the start, the update, support for instantiate and debug, and all kinds of different bits of code like that. Okay? But if we want this object to be aware of the networking, we actually have to derive it from a different class, network behavior. Now, network behavior is itself derived from mono behavior. So we are still a mono behavior. We're just now upgraded to a network mono behavior. And that gives us access to a couple of new things. Well, several new functions, as well as quite a few new variables to check, such as if is local player. Okay? And we could be equal true or equal false. Again, so I'm going to check for false. You could just do this, but I like, especially my tutorials, to be super explicit. If local player is false, this object belongs to another player. So yeah, we could do something else. For now, we're just going to return. There we go. So we're gonna bail at this point. We're not going to do anything else. Now, this code is still super wrong. But let's get back to that. There's another thing we could do. We could check for, what is it? Authority? Has authority. Or local player authority. These are all different ways to say, I personally am allowed to mess with this object. These would all be true. Has authority, has local authority, is local player, will all be true for my personal player object and will all be false for someone else's player object. The reason they have all those things is because it's something that's going to come up a little bit later. Well, actually, with this player unit. This player unit is not going to be is local player. It's not a game object that represents a player. However, it will be a game object that is going to be owned by a player. One player is going to have authority over this object. That's not always the case. There are many networked objects that will exist that no player has authority over, only the server does. Now, again, sometimes the server will also be a client, but let's, again, we've got to sort of partition that in our brain here because it helps us organize our code. Okay, so now this code, this section here will only run if we're actually the local player. The problem is this still doesn't do what we want. Instantiate only creates an object on the local computer. Even if it has a network identity, or transform, or any of those things, it still will not exist on the network, and therefore not on any other client unless network server.spawn is called on this object. Network server.spawn is the only way to make a game object appear on all the client computers. So if you want something to be like actually on the network and on everyone's computer, you have to call network server.spawn. Now, the other thing is the word server in here should be a bit of a clue that only the server can run this line. Only the server. If I'm a client and someone else is the server, I actually am not able to call network server.spawn. It just won't work. It'll say like missing server or something like that. So we need to create this player unit prefab. We actually have to create it on the server and then get the server to tell every client, okay, this is a thing now that exists. How do we do that? Well, that's going to be next episode. Thank you very much for watching, folks. Hopefully, we are moving quickly enough to keep people motivated, but we are adding a lot of extra depth compared to, some of the stuff I'm finding out there. And hopefully we're going to design things in such a way that you'll have true flexibility in your networking applications, and you'll be able to use this to make basically anything. Cross our fingers. See you next time. Thank you to all the January Patreon supporters and these Mic Check supporters at Yukofin, Lurking Ninja, Dubious Sir Curl, Tiburon, Mighty Mix, Pavel Zdanov, Adam Keenan, Michael McClintock, Aaron Doibson, Rarskal, Gurko Dries, Jesper Bisgard, Julien Gelafon, Soren Tried Anderson, Marisfield Vold, Speedy Savant, Steven Stager, Thomas Oberson, Jason Yanity, Easter Egg Productions, Neil Blakey, Milner, and everyone who watched, shared, favorited, and subscribed. Thank you so very much.